conference web page. So the recording is on, and by saying this, I will now stop sharing and hand over to Andre. Andre, please, the floor is yours.
Thank you, Vlado. I will share my screen. Okay. Okay. Good afternoon to everyone. Can you see my screen, Vlado?
Yes, we can see.
Yes.
Okay, perfect. Just okay. So good afternoon to everyone. I would like to wish you welcome on the virtual workshop on exploring and applying Msp principles with Maritime Spatial Planning. My name is Andre Abramic. I work in Eco-Aqua Institute at University Las Palmas de Gran Canaria. And today I'm here with Vlado, with the session host. It's Daria Lichtenegger from Environmental Agency. Vlado is, of course, from organization of the Joint Research Center. And also today we have colleagues from a system mechanism, Chris McDowell and Climat de Pont, which is actually action that supports European Commission, DG Mare, and EASME within the implementation for the Maritime Spatial Planning, and of course supporting the member states within this. Well, today we have a workshop that was originally was idea to have it in Dubrovnik, but for the reason that we all know, very known reason, this is we passed to the virtual format. And today we are going to have 10 presentations, which are going to be flash one, the fast one. We are trying to do this very dynamically. So there is a first session where we are going to talk about Msp data, which is actually needed for the development of the plans, what is the necessary for the development, and also then we're going to have a short session of the questions and answers. And then there is a second session where we actually want to have a session have a two presentation on already developed solution on the Inspire data models. There is a solution from the base map, one solution from Msp project, and also one solution that was developed on top of it. And at the end of the workshop, we are going to have conclusion and wrap up from colleague from the system mechanism, Climat de Pont. So just, I don't know if Vlado explained the rules. So before we start, I would just say, if your bandwidth allow you, please share your camera and unmute you. And I think we can go within the first presenter. The first presenter is Michael Saline. He works with the European Environment Agency. He has more than 7 years experience with the international institutions. Before the EA, he was working in Joint Research Center, and he was working on European Atlas of the Sea, Mar Atlas, I'm sure you know for it. Also, Michael holds the PhD in New Technologies and Information Territory Environment, which he finalized on University of Venice. So, Michael, the floor is yours.
Okay, thank you, Andre, and good afternoon, everybody. Thank you for inviting me in this workshop. So, I will do my best to stay within the 5 minutes allowed. So, if you allow me, I will tell you when to move from slide to slide. So, we can start now with the next one. I will present you, I will guide you through the following points during the presentation, so it doesn't don't have to go through this to lose time. So next one, please. I will present today the preliminary result and achievement of the project UNICEF2 from the data perspective managed by the EA in cooperation with UNetMap. to start, I would like to bring a little bit of context. This project fell into the Mediterranean Initiative H2020. It's under.
Can you go near to the microphone that we can hear you better, please?
Really? Oh, sorry. Okay, so I just wanted to bring a little bit of context. So this project, it fell into the Mediterranean Initiative H2020, which is under the political umbrella of the Union for the Mediterranean, UFM, with the goal to assess the depollution of the Mediterranean by 2020. So the infrastructure component for the data reporting represents one of the key pillars of the project. And the key task is to put in place the H2020 data flow, so to collect data from the countries from the southern part of the Mediterranean. So my role in this project has consisted in working closely with colleagues from Interact in charge of the infrastructure for the Barcelona Convention to develop and optimize the work. So the project is ending this year, but the neighboring policy is still in the Europe, it's in the European Green Deal. So if you can change, Andre, please. So the H2020 data flow that is not only made of technical development, but he has requested a series of activities, among which the capacity building to work with the country to reinforce their national information system, and also a strong network of environment ministry and statistics offices around the 9 neighboring countries and the Balkans. And also it has requested to advance the progress on the data policy for the whole Mediterranean region, taking into inspiration the EU data policy that is oriented toward the CC BY license type. The next one, please. So, Andre, yes, in terms of data of H2020 data flow, we have organized this around 3 thematic areas and through a series of indicators. So this is what is the content part is that we have developed a series of indicators related to waste that link the national waste management in the countries with the marine litter in coastal area, the water indicators that study the discharge of untreated wastewater in the sea and the loads of nutrients whose microbiological concentration in line with the Basin Water Directive. And then finally, the industrial emission indicator that measure the release of nutrients from industry in the sea. So all this, one of the output of this data collection is the second Mediterranean assessment report that is under preparation now. So next one, please. In terms of development, of technical development, as I mentioned before, at the EA we have worked closely with Interact that has the mandate to develop all the reporting system for the Barcelona Convention. And together, we have worked on the delivery of the Interact Data Center, which is a reporting platform that has the similar architecture of the ReportNet information system that we use at the EA to organize the country reporting. So most important thing is that the information system, the ReportNet and the Interact Data Center are synchronized, are integrated together, and they are interoperable. They work together. So next one, please. So the result of this exercise of the H2020 reporting within this project of ENISI are accessible via this series of online dashboards that show the data flow and that monitor the data flow, let's say, and that show the capacity of the country from the southern part to report using standard data and using platform such as the data center. So what we have done is to distribute tables, structured tables, to the disposal of the countries. We have also organized the data flow using different other formats such as XML, for instance, associated with schema validation. And we can also progress in this using other forms like web forms with field from other reporting obligations. So what we are doing is to run a quality control check to ensure the consistency and the comparability of the data. And you can see the result here on the screen, and it's accessible online. Obviously, the situation is rather different among the countries, but you will see. Next one, please. So, in addition to the reporting data center from Interact, we have also developed this Interact has also developed this spatial data infrastructure for the Barcelona Convention that we have used in the framework of this the project to launch a spatial data code. So this spatial data infrastructure is associated with Metadata Catalogues, which is Msp compliant and respectful of ISO standards. And the objective of the project was also to investigate how much we can federate this SDI with the national SDIs in the country. So next one, and I can conclude. The intention of the project is to collect data, to have a full understanding of the state of the marine Mediterranean environment. So to do so, we are building on the MSD, the Marine Strategy Framework Directive experience that we already have at the EU. So the major long-term objective is to ensure that there is a full convergence between the MSD and the ECAP process in the Mediterranean Sea, which is similar, and to try as much as possible to avoid the duplication of the repetitive efforts. So the southern Mediterranean country, in the context of the Barcelona Convention, are starting now to collect IMAP data, which is this integrated monitoring and assessment program. And in somehow the work that we have been developing in this United States project has paved the way to this integration, because one of our indicators, for instance, correspond to one of these IMAP community indicators regarding the key nutrients concentration in water column. And I would invite you to see to check the Wise Marine portal, which is online now, where we have this result, and also where the dashboard are available. And thank you for your attention.
Okay, thank you, Michael. We had a little bit problem here to hear you properly. I hope the participants had a chance to hear you better than us, but okay. Thank you. Maybe questions, we will leave it for the end of the session. Now we are going to our next presenter. Our next presenter is Yolanda Sagariminaga. She works in Marine Research Division of ASTI, Spain. She holds a master in integrated land spatial management, and what is also very important, Yolanda has very long experience in marine data management and Earth observation system. So she works with different standards, OGC, ISO, Inspire, but also she manages lots of applications. And what I would really like, she also participated in the number of European but also international projects. And one which I would really like to mention is that Yolanda is working on the HumanNet human activities lot. So Yolanda, please unmute yourself, and if you can, if your bandwidth, we'll put video on.
Thank you. Can you hear me well?
If you can come a little bit near to the microphone, maybe it would be better.
Now better?
Yes.
Okay, thanks. All right. Yeah. So what I'm going to describe in this workshop is the work we have done under the eModNet Human Activities project concerning the harmonization of the datasets we produce to inspire specifically in the data specifications issue, because the Inspire requirements related to metadata and OGC web services are already active in the portal. So this relates to the data specifications specifically. Next, please. So in fact, this work already started some years ago. And in February 2018, we published a report with the outcomes of the first analysis we made, in which we identified 17 different Inspire application schemas that were potentially applicable or assignable to the 66 ModNet human activities datasets. The thematic alignment to the Inspire data models was quite different from datasets. Some were quite good aligned, and others, the alignment was weaker. Another interesting, or important thing that we found is that the code lists required by Inspire in different data models were often incomplete to well define the information we had in ModNet datasets. And sometimes also different code lists from different data models that addressed similar information had semantic inconsistencies and different definitions. So the outcomes from this work for us was that the harmonization of the ModNet datasets using these identified Inspire models was going to be technically difficult, and also the results wouldn't be useful or satisfactory. However, recently we heard about the approach that has been proposed within the Mars project, consisting in using just a model from the Inspire land use theme to harmonize the marine spatial planning data. And we thought that this approach could also be interesting for the datasets in ModNet, as we produce similar human activities data. So in this new round of the analysis, we have tried to harmonize the human activities datasets to the Inspire land use theme data models. Next, please. So the first step was to select the most appropriate Inspire model. The Inspire land use theme includes 5 data models or application schemas, and in our case, the most appropriate one was the sample land use model. For example, the marine spatial planning data is more aligned to the plan land use data model in Inspire. But as in our case, our data represent existing maritime uses, the sample land use is more appropriate. Moreover, our data sets are, most of our data sets are represented with points. So from these existing land use, sample land use, and grid land use models from Inspire, the most adequate one was the sample land use. And for the polygon and polylines layers that we also have in ModNet, we made transformations to point, retaining the centroids for polygons and the vertices for polylines. In this sample land use model, there is also an important attribute, which is the Hilux land use, in which we use elements from the Hilux land use code list to define exactly which is the activity we are representing. And also an important thing that we saw is that this data model, although retains the information on the definition of the activity, its location, and its temporal validity, however, it does not include other information that we already have in the ModNet data sets related with the, for example, intensity of the activity, or the ownership of some infrastructures, etc. Next, please. So technically, the harmonization process consisted in two big tasks. The first one was to accommodate the original ModNet data sets to the Inspire data model selected. And for that, we had to make geometrical transformations to points. We have also to select from the Hilux code list the best elements to define our activities. And we use the attribute called specific land use to fill in with elements from the Msp Hilux extended code list, also proposed within the Mars project, which is an extension of the original Inspire Hilux land use, which was proposed to hold more elements that the original code list didn't have to define the maritime uses. Even though sometimes we didn't found even in this second vocabulary appropriate elements to define our activities. So in those cases, we created our own information and filled this attribute with this information. Then also we created Inspire required attributes in the model and mapped the original information against this and transferred this information to these new attributes. In this step, we used the local ID attribute and the specific land use attribute to fill in information from the original data sets that cannot be directly transferred to an attribute in the Inspire data model as a concatenation of information from the original data sets. This was made to try to minimize the loss of information from original data sets. Although we are quite aware that this is not a very clean solution, we did that, and maybe this approach will be revised if better solution is found. Then, whenever available, we filled in also the valid from and valid to fields with the information of the temporal information from the original data sets. And in this step, we had to transfer from string dates types to date formats, which in fact was an improvement to the original ModNet data sets. The second big bunch of tasks was related to encoding. Once we had a single shapefile, in this case we work with shapefile Also, we work with GeoPackage, but I will explain why we use shapefile finally. Is that once we had all the data, the human activities data merged into one single shapefile with the format of this selected Msp data model, we upload it into our GeoServer node to publish it via WFS with an encoding format required by Msp, which is a GML, a nested GML. And this was done using a plugin, a GeoServer plugin called Application Schema Plugin, and making a mapping XML file to transform from the original shapefile to the Msp required GML. In this case, we found that, for example, GeoPackage, this plugin didn't work well with, for GeoPackage, so we had to work with shapefile, even if this GeoPackage has some advantages related to the shapefile. Next, please. So the conclusions of the results of this task were that for data model, we find that harmonizing our data sets to Msp data model is an improvement. I mean, we improve in coherence related to information concerning the location and temporal validity of the futures we have. Also, these new data sets gets closer to the integration or interoperability with other human activities data sets that also could use this data model. However, there are two disadvantages found that have to do with the fact that Hilux land use code list is not specific enough to well define all the maritime activities. And also, and this is more important, is that this Msp model does not have room for other associated information that sometimes is very important to be taken into account related to the human activities at sea. And related to the encoding phase, in fact, here we didn't find many advantages because the phase or the work done to get this encoding was quite time consuming and complex, and also we found that there is very few documentation and tools to help in this process. Also, serving this complex DML with GeoServer has is less performant than serving the same data set via via single GML produced with GeoServer. And also, not all GIS clients are able to correctly read the complex GMLs. So in this case, our recommendation would be to allow flat GMLs to be used as Msp compliant data sets. And yes, next please. And that's I think all I had to say. We are going to publish all the resources that have been generated in this exercise very soon. So we will publish this in a Emonet portal blog. And these resources include a detailed report with all the analysis made, the resulting data sets, and also the mapping file, XML files that we have created. Thanks very much for your attention.
Thank you, Yolanda. I think very interesting solution to use the sample land use data model. Okay, we can go within the next presenter. It's Alessandro Stratta, who is a researcher at National Research Center of Italy. First, he was working in Institute for Marine Science. Now he's working in the Research Institute for Hydrogeology Protection. He was also part of the Msp Data Specification team. He will present behalf tools for Msp Research Group, which are developing special data infrastructure and decision support tools for Maritime Spatial Planning. Alessandro, please unmute yourself, and the floor is yours.
Thank you, Andre. Just a confirmation about the volume quality of the voice.
Yeah, it's very good.
Okay, thank you. So as Andre mentioned, I will briefly talk to you today about some experience on web portals and software tools supporting MSP, specifically in the Adriatic-Ionia region, but also at Mediterranean Sea scale. And that those are the names of the people on this group of research. Next, please. I have only 3 slides, very condensed and simple, let's say. And the first one is about the flow of work and projects we have been supporting during the last, let's say, 7 years, starting from the first experience on the Agiplan project and portal, because one of the main outputs was a geoportal with data and interoperable services about Adriatic and Ionian region. One of the first projects on the MSP in Europe and specifically in the Mediterranean area. Then we have on the Ritmare, an Italian flagship project. We had a focus on the Regione Emilia-Romagna to apply principles and data related to MSP. And then we moved at the Mediterranean scale with other people also involved in this workshop with Supreme and SimWestMed projects at the scale of the East and West Mediterranean, where we applied rules, guidelines. We tried to draft a way towards MSP in the Mediterranean. And finally, there are to mention about 2 recent and ongoing projects, Porto di Mare, producing a portal, a geoportal, integrated geoportal in the Adriatic and Ionian region, plus tools, and we'll talk about that a bit later. And then the MSP Med, a project at the Mediterranean scale with national authorities included in the partnership to support really the implementation of the directive on MSP at the Mediterranean scale. Next. So this is one slide with some principles we are trying to stick with on this path. And so not only to manage and use data, but create decision support systems for MSP using, let's say, only open source technological stack and software, starting from the GeoNode for the interface and behind the scene GeoServer for the services, Seeker for metadata, Swagger for the API, or using also QGIS for desktop. And with a collaborative and transparent process, publishing software code on GitHub and publishing open data from what we produce in the context of the open science. We are using standard interoperable services, mainly OGC ones, but not only the standard ones, but moving also with the SOS, the Sensor Observation Service, and now also using open APIs. Not yet Inspire compliant, but this is the next step. So in this path, we want to move forward also together with the group of people talking today. And also a strong collaboration with other initiatives. And we have representatives today from Amonet, Copernicus. We're using OBIS because the network of services and collaboration is fundamental at pan-European level and with cross-border issues. And we have a specific focus on models for the evaluation of cumulative impacts and coexistence of multiple uses in the marine environment. Next, Andre. And this is the name of the research group, but also the software suite that we are developing, Tools for MSP. That is a geo platform based on the GeoNode, as I mentioned before, and we're using it to collect data, to manage, to publish them. Some of them are public for interaction. Some of them are technically inside for us to be processed. And on top of this geo platform, there are modules and APIs that allow other geo platform or our own to interact with tools that we are developing. And I was mentioning cumulative impacts and multi-use of the sea. And especially this has been concretized on the Porto di Mare geoportal, where the standard, let's say, geoportal with data, interoperable services, view, download, it's going to be integrated with processing services, with integrated modules that are calling APIs and running these modules, producing outputs and statistics that are immediately integrated themselves in the portal. So they are then served as geospatial layers through interoperable services. This is the workflow we are having with the steps in addition that are going towards an integration of also of the data model. This is something that we are learning together with you, and we are going to think to implement in the future. Next, just to thank you and to have to give you the email for contacts for the research group. Thank you.
Thank you, Alessandro. This was very, very interesting. And actually, in the 5 minutes, you were really respecting the time. Thank you a lot.
Thank you.
I'm sure there are going to be after questions for you. We go within the next presentation. Next presentation is Marine Strategy Framework Directive and Directive on Marine Spatial Planning requirement for marine spatial plans for Montenegro. This is going to be presented by Marina Markovic. She's working in UN Environment Mediterranean Action Plan PAPRAC office, which is in Split in Croatia. Marina is working on lots of international projects that are actually focused in the Mediterranean and Adriatic. Also, she is focused within the projects that are related on the integrated coastal zone management and maritime spatial planning. She holds 2 master's degrees in the coastal management, and currently she's coordinating different activities toward common approach for MSP in Adriatic. Marina, glad to have you with us. You have 5 minutes for your presentation. Please.
Hello, thank you, Andre, for inviting me. I don't know if you can hear me or see me. I hope so. I'm still getting used to all these web conferences. I really miss the good old days when we could all meet and talk in live. Okay, so just to say, unfortunately, the first presentation was not, we could not hear it very well, but to some extent, what I want to present today is linked to the info systems presented in the first presentation in the Mediterranean. Because working in the UNEP map system, what we want to do is use all the information coming from either European directives or this so-called integrated monitoring and assessment program, which is very much same as, I don't know, Marine Strategy Framework Directive and to some extent Water Framework Directive, but applicable for the rest of the Mediterranean, I mean outside the EU. So the idea is to use all the information and data coming from this very demanding process, let's say, to collect all the sets of information about the sea and to use them not only to monitor the progress towards the good environmental status, but also to use it as the environmental input for the for the preparation of MSP. So in the left corner, down corner of this slide, you could see, similar to what Alessandro was presenting, some kind of cumulative assessments, the results of it, but only using the sets of data coming from these, let's say, MSFD related initiatives. Yes, please, next slide. So just to show, yeah, so to say, the MSFD and this so-called IMAP process are very good in this sense, because they give us the direction on what kind of environmental information we should collect in these 11 different, let's say, topics, from noise, contaminants, marine litter, etc. What we also added to the European directives is this coastal ecosystem, which contributes to the topic of land-sea interactions. And all these data, all these, let's say, sets of information that need to be collected are also grouped into the indicators, which also helps us a little bit more on what data sets we should focus on. But I have to say that not all of them, of course, are applicable to MSP. So we need to do some kind of, I mean, we cannot even focus on all of them, or those that we can focus on need a little bit of adjustment. So if you can show the next slide. For example, of course, one of the information required is the distribution of the habitat. So obviously this is one of the easy ones. So once you have the distribution of habitats, maybe you can do some assessments, evaluation on the levels of the priority and the values of different habitats in the sea. Next slide. But this is, for example, but based on these directives and these info systems that we need to report on, for example, data on fisheries are not so easy and simple. These little dots that you see and yellow lines are actually transects on which you collect your data. Let's say this is for the demersal fisheries. So what is necessary is to do a little bit of interpretation of these data in order to be usable for MSP. So on the next slide is the interpolation using the GIS systems on how this could look like. So this is the distribution of the demersal species. The next slide. Similar is for the pollution. So here the initial information that go into the databases and the data sets that we report on are the points on monitoring stations with some values, etc. But to be usable for the MSP, next slide, we also need to do some interpretation of this data to be able to have the real spatial distribution of, for example, in this case is the level of TRIX index in the sea, which corresponds to the level of eutrophication. Next slide. So to conclude, let me say that in the Mediterranean, the IMAP system or MSFD is very useful if we want to speak about marine spatial planning, because it gives us the initial very good sets of data. Which are quite useful, but at the same time that they really require a lot of elaboration to be spatially used for the MSP. And this requires some skills and capacities of national experts where we really need to work with them and to be able to make the proper interpretation of data. Thank you.
Thank you, Marina, a lot. This was very interesting presentation. It's very interesting to see that accession country as Montenegro actually is applying the principles of the European legislation. So the next presentation is about the project PASMAR, which actually initiated in 2017. We are almost finished it. We are going to finalize this project in September. I don't want to talk about the project. I will just talk about the data management that we did within the Inspire, we aligned within Inspire. Only thing what I need to say, this is the MSP project, which actually needs quite a lot of information, lots of data that need to be collected. And what we understand on the beginning that we need to establish efficient data flow for this data collection. And to do this, we actually put the people together in partners in the one room, and we had the partners who actually already had established data infrastructure operative, and they can actually support this data flow development. But we also have partners who has been involved in the data collection, but they didn't have. They cannot use any special data infrastructure. So for this, we show them how to develop metadata, but what is more important, we show them how to use GeoServer, how to share data with the GeoServer, which we installed on our server, and we just installed 3 versions, one for the Azores, one for the Madeira, and one for the Canaries. So the partners who actually didn't have access to special data infrastructure to share, they can use this very simple data infrastructure, which actually allow to data flow within the project, and also to share the data within the general public. Second thing, what we saw within the project, we saw that there is really lots of things were coming, and we said, okay, we cannot just we need to structure this, and then we developed something that we called Plasma Msp Data. It has 5 clusters. The first cluster is the marine data, which is again very, very broad and very difficult to structure it. But we used Marine Strategy Framework directives, which was mentioned a few times today, and we used good environmental status, which actually provide kind of the 11 components of the marine environment that we were following for data collection. The second cluster was the marine protected areas. That collection was going very easy because we just collect the data and harvest the data from the databases of European Environmental Agency, Natura 2000 and CDV. And this was very good because the database not only provide the polygons, they also provide you information on what are the environmental targets that we can understand if we can combine it within the maritime. We collected data about the current maritime activities, of course, but also we wanted to know what is going on in the coastal area. And so we collected the data about the coastal land use, which we actually used Copernicus land service. And for the oceanography, for the temperature, currents, wind, which is very relevant for the suitability of different maritime activities, we used Copernicus Maritime Service. So one thing what was, when we were using the data products for EEA from the Copernicus, from the MMnet, these data sets were actually harmonized. But when we were working within the local data set, the national data set, and a very good example is the data set of marine habitats that we used for Canary Islands. It is a very, very detailed data set and very useful. It provides the information about the marine habitats until 50 meters of depth. It has a very detailed, but when we start to work with it, we see, okay, there is something strange because we have more than 180 habitat classification. Then we look at before and we understand, okay, this data set has 7 different data structures, 7 different classification, as well developed by 7 different companies, this survey. So that this was a very good task. We used the Inspire Habitat model for the harmonization of this data set. We use the classification, which is European Union Nature Information System, UNIS, for the classification habitats, and the Marine Strategy Framework Directive classification system. And this actually allows us to integrate within the MMnet habitat dataset, which was actually much more broad, but didn't have that detail for the 50 meters of this. You can see it on the right side. So when we developed this dataset, there was a lot of interest from end users for this dataset, and we showed them, we pointed on the Inspire services, and they said, okay, we had a problem to use this, and to make more approachable for the end users, we plain flat data models of the habitat, and this was actually working quite fine with it. The next thing what we did within the project, we developed the metadata catalogues. We have 1,000 records for the metadata services and the data set that are relevant for the Micronesian spatial planning. We also developed kind of API for the services catalog, where you can actually take very simply copy the URL and put it in your GIS. And also we developed different GeoViewers, thematic GeoViewers, so like on the habitat, on the maritime spatial planning, etc. So one thing, now we are finalizing the project, and actually we have a quite good result. And one of the reasons is the efficient data management. So the point is that analysis that we delivered for the introduction of the offshore wind energy in the Canaries, now because we have a harmonized data set for the Azores and for the Madeira, the same analysis that we delivered for the Canaries, we can apply it for the Madeira and then for the Azores. The analysis of extension of the aquaculture that we delivered for the Madeira, now we can apply it for the Canaries and the Azores. And the analysis that we delivered within the Azores of the mineral extraction, we can apply it. So the point is that this first effort on the data flow and the harmonization actually pointed very, very good results. So this was it. Now I would like to go within the next presenter. The next presenter is Fabrice Massoud. He is a training and educational manager for Mercator Ocean International, which is actually managing the Copernicus Marine Environment Monitoring Service. He has a background in science and application, which he holds master's degree. Also, he has a professional experience in visualization software and scientific mediation. Fabrice, the floor is yours.
Thank you, Andres. I'm very pleased to be here with you. So I will introduce you the Copernicus Marine Service and the capacity to help and to support the implementation of MSP or other EU policies. So next slide. So the Copernicus Marine Service has been designed to respond to issues emerging in the environmental, business and scientific sectors. It can be defined as an integrated service, an open and free service, providing access to a single catalog of core products. It's a reliable and sustainable service. And we have also, it's a service which is OGC, WMS and Inspire compliant. Next slide. So the data can come from different sources. They cover different regions and different temporal scales with different frequencies of updates. The service tries to offer information about the state of the blue ocean, the physical one, the green ocean, and the white ocean. And these data are useful in many domains, like the protection of the biodiversity, safety at sea, and the maritime routing, the fight against marine pollution, the sustainable exploration of the coastal environment and marine resources, marine energy, climate monitoring, and the implementation of EU policy like MSP or MSFD. Next slide, please. So with the different sources of data, we try to cover wide user requirements. And this is one of the assets of the service, is the diversity of harmonized products into this catalog. Next slide. Supporting users and sharing knowledge is are part of the Copernicus Marine Service commitments. We regularly organize events to meet the communities of users, like the MSFD event last year in Brussels. And through the different regional training workshops we can organize, we try to meet the new community of user requirements. And through this new format of online training session, we try to demonstrate how to combine different sources of data, of different data portals, and specifically with sessions on GIS tools. It's a new, fresh new in our training session to propose this kind of session. Next slide. A part of the website, you will find pages dedicated to use cases. It's important for us to share with downstream users what they are doing with the data and how they are, and their capability to unleash the power of this data. And it's also very important to show to other potential users what they can do. And I put just two examples of the Plasma project you introduced, Andrzej, before me, and the Siwetra project led by CIMA. These two examples demonstrate how the Copernicus Marine Service can support marine spatial planning. Next slide. The strategy of the service in the future is to consolidate the global positioning of the Copernicus Marine Service as a reference provider marine information and services. The main goal will be to continue to improve our relationship with users and reach new community by adapting our catalog and the format of our products. For your information, next July, during the next release of the catalog, so we will put online some products in a shapefile format. So it's fresh new to announce that, because the majority of the products are available on the catalog of the Copernicus Marine Service are in the NetCDF format. So it's a step in the direction of new communities to change a little bit this format. The other goals will be to upgrade our integrated monitoring and forecasting systems and strengthen the offer, and to propose state-of-the-art cloud-based services and enhance synergies with existing pan-European initiatives. Next slide. Thank you.
Okay, thank you, Fabrice, a lot. This was a very good presentation which presented the service. I think now it's very clear what can be actually reused for the Maritime Spatial Planning. Thank you again. Our next presenter is Irene Del Barrio. She works with the European Environment Agency, and she supports actually European Commission DG Environment in reporting with Marine Strategy Framework Directive. She's co-chairing the working group on data, information knowledge exchange, maybe you heard for VGDITE, and technical group on marine data and IT, TG data. Also, I think it's very relevant for say that she's coordinating development of marine water information system for you. So Irene, the floor is yours. Maybe you can unmute yourself and you can start your presentation.
Thank you very much, Andre, and good afternoon to everyone. It is a challenge to speak only in 5 minutes about what I've been doing for 5 years now, but I'll try. So the first slide that I wanted to show is on the timeline of the directive. You can go to the next slide, Andre, thanks. This is the timeline of the directive. The directive is, as you know, the main instrument to protect Europe's seas, our seas and oceans. And it was adopted in 2008 with the aim of achieving a good environmental status of our marine waters by 2020, so now. It was quite ambitious, and well, the timeline was definitely very short to achieve this objective, and you can see there the main items that have constrained, if you want, the implementation of the directive, which was in the first hand only by 2010. Let's say the VCPs, the instructions for the assessments that had to be performed in 2012 were adopted. This was the first year's decision. And then, after analyzing the assessments performed by the countries in 2012, it was agreed that this decision had to be revised, and it was only an updated one was only adopted in 2017, just 1 year before the next assessments had to be done, which was in 2018. So it has been quite well, complicated to get to this year to achieve a good environmental status, where actually not even the proper guidelines on how to assess the good environmental status, or how to determine or assess it, was in place for a while. So if we go to the next slide, these are the main reporting obligations on the directive, the articles that have to be reported. Reporting notification to the Commission. So where member states have to notify to the Commission about the implementation of these articles. For this, we agree with the member states within Working Group DIC. We agree on the content that has to be reported under each article and the formats. And then just to note here that the information that is reported by the countries is usually categorical. So the countries don't report data, like raw data, but a number of questions of data information that is about well, whether, for example, the most simplistic one is whether the GS has been achieved or not. And in 2018, we were requesting if it had already been achieved, if it would be achieved by 2020, which was the deadline, or if it would be achieved by later than 2020, etc. No? These kind of things. It's categorical information, while the data behind all these assessments performed, actually, they don't have to be reported, but they have to be made available. They have to be published. And this is under Article 19.3, and you can see there. So the data gathered within the monitoring programs, as well as the data resulting from the assessments, so the aggregated data, both type of data have to be made available according to the Inspire standards on top of it. So we can maybe move to the next slide. So for the reporting, there's a platform, ReportNet, that is well managed by us, by the EA, where you have two images here. The one behind is where you can see the country folders structure. So each country has a folder, and within the folder of each country, there are different folders as well on the, for example, EU obligations or other things. Within the EU obligations one, you will find the folders corresponding to the Marine Strategy Framework Directive reporting obligations. And then in the second image is the CDR, so the Central Data Repository help page for the MSFD, where we have all the folders for each of the reporting obligations. And in each folder, you can find the guidance, schemas, and tools that have been used or have to be used. For example, in this year, there is the reporting of the updated monitoring programs that will start in July. And so here's all the documentation available to the public on the guidelines that the countries have to follow in regards to the reporting of the MSFD obligations. Then on the next slide, I want to show a very basic diagram of the MSFD data flow. So the countries report XMLs. So up to now, what we mainly use for the reporting is XMLs for the assessments and the targets and so on. While separately, we also ask for shape files on the reporting units, the Marine reporting units. The XMLs in the last reporting round in 2018, which was the update of the GS assessments and the GS determinations and the targets, we adopted a bit a spatial approach where member states within the XML member states have to report by each geographical area, by each reporting unit. They had to report the assessments performed, so which of the descriptors have been assessed for each for this reporting unit, and so on. So everything hanging from the Marine reporting units. And this is for the assessments. While, for example, for the GS determination, meaning what GS means, then this was the other way around. The member states have to define GS for each of the descriptors and criteria, and then they have to say to which Marine reporting units those determinations of GS apply. So the other way around. It depends on the article, but well, in any case, we work with XMLs and shapefiles, and there's always the countries they always produce PDF files that because they run public consultation processes and so on, and for them the PDF files, these files are in some cases even adopted at the national level by the Council of Ministers, maybe, or something like very high level. So it's their official documents. So they always want to somehow report them as well. So we also have a folder within the CDR for them to upload their PDF files. Then from CDR we harvest this information from the XMLs and the shapefiles, obviously not the PDF, into SQL databases. We have a test database where we actually run the QC as well. From CDR we harvest it into a test database, and we run some QC, and we send back some information in HTML, And then we have another one, a production database, where we have harvest all the information once the envelopes are released. And then we have a public database that is serving some of the add-on services for Wise Marine. So, from our databases in SQL, we are reading the data from the databases from some from some applications, and then as well directly from Wise Marine via some add-on services. So Wise Marine, if you go to the next slide, and I will finish here. Currently, Wise Marine was launched in 2017 with almost no information in it, because it was announced long ago, like by 2010 or something like this, 2009 or 10. The Commission announced that they were going to launch a website to make available all the information reported under the MSFD and so on, but this was never funded until. But it was so it only started as a project in 2016, and in 2017, after a long while of having announced this, there was the decision of launching it, at least for member states to see that something was ongoing, that the page was more or less a reality already, and it was going to be it was going to be filled in slowly with the reporting information as it started coming. Well, so after having said this, we have now been working in the last year on an upgrade of the website. We have upgraded the plain version, but also the contents, and we have prepared the different products with the MSFD reporting information that will be available in the website by the end of the month. The main ones being, so as you can see there's a section on data, maps, and tools, and within this section there's a subsection on MSFD reporting information and products, where there will be what we call the MSFD reporting data explorer, where all the reporting data will be made available and downloadable. So queryable and downloadable. There will be the MSFD spatial reference data sets that are already available in RSDI actually, but there will be a link, a dedicated link there to access them. It's the regions and subregions, MSFD regions and subregions, the marine waters of member states, and the marine reporting units from the first reporting period that goes from 2012 to 2018, and the second reporting period that started in 2018. And then we will also have, there's also a subsection on visualization tools dashboards with the displaying the GS assessments reported by the countries. So I will stop here. All of this will be available, as I said, by the end of June. Actually, next week we are moving to production everything, but we will be testing the performance of the site and so on, if there are bugs and so on, for a while, until announcing the general level that this has been launched. So yes, that's it from my side. Thank you.
Thank you, Irene, a lot for this update of especially that we can expect the new update on the marine wise. This is very interesting. We should have a questions and answers session, but I would like to skip it and include it within the last session because we are a little bit late with time. And to that, we will go with our next presenter, which is Andrzej Milosz. He is a GIS developer with the Helcom Secretariat, where he works from 2016. He works on the project TAPAS Baltic Lines international projects within the Helcom, and he actually was developing base maps, all the services and products within the Helcom. Unfortunately, Andrzej was not able to come to present today here, so this is why we have a Florent Nicolas here. He's also from Helcom, project coordinator. So Florent, please, the floor is yours.
Yes, thank you very much. Good afternoon, everyone. I hope you can see and hear me properly.
Yes, yes.
Okay, hearing is the most important, actually.
Yeah.
I will try to be fast. So let's talk about transboundary MSP output data for now. We will discuss a bit about the Msp Data Model and the tool called Base Maps that was developed within Helcom. And there is actually a small MSP data validation tool within Base Maps. So we will have a quick chat about this. Next slide, please. So it's important as background information to know that in the Baltic Sea region, we have MSP data expert subgroup focused on data harmonization only for the Baltic Sea region. And for the last years, it had the data group, the data expert subgroup, sorry, was actually working on guidelines on transboundary MSP output data. And it has been approved as an official guideline for the region by VASAB and Helcom, which are the two organizations managing those the data expert subgroup. The guidelines are actually technical data specification for Maritime Spatial Plan area and also planned CUs. So those are the 2 points that we will discuss now. Next slide, please. Thank you. The Maritime Spatial Plan area, it's one of the side within the output data on base maps, and it's actually data sets provided by the national authorities, by the countries, and it's just to have a general overview of the MSP process in the region per countries. It's actually from planning documents, so they are like official information. And it was legally adopted by the authority responsible for MSP at the national level. It's actually based on the Inspire land use specifications. This is quite important to note, and it works very nicely because, as you can see, the attribute name are quite generic. There are few attributes because we have several countries, so it's important to be generic to be sure that it can work for all of the countries. As you can see on the map, on the small legend, there are 4 types. So enforce, elaboration phase, preparation for elaboration, and the obsolete, which is the last one. Next slide, please. Thank you. The planned CUs is the second part of this output data. It's actually the spatial extent of the existing planned or potential development of the activities at sea. So these are actually in the table on the left. You can see that there are different attributes for them. So it's actually to categorize the sea area. We have priority use, reserved use, allowed use, and restricted use. You have the definition here. I'll try to go fast on this because you will have the presentation for later anyway. All of those areas are actually polygons, and the data model behind this is based on column. It's a flat data model, and each of those polygons are lines, and so they can be characterized by different attributes, by different CUs types. It will be a bit easier to understand after when I will do a live demo. Actually, I will do the live demo right now. So I will try to share my screen with you. Screen share. Yes. So this is, I hope you can see my screen now.
Yes.
Yes, we do. Yes, we do.
Perfect. So this is base maps. There is a part about input data, but we will not talk about this today. And there is this part about output data. When I click here, I have the plan area, as we discussed about, where you have actually the status of the national waters. When you actually click on it, you have more information, official title, alternative title, English title, because of course sometimes it's not in English, and so on. And you have different attributes. They are not. It's not an obligation for the countries to put all of those attributes, but some of them are extremely important, and it is an obligation actually. When we go in the plan C uses, so this is a bit the tricky part. This is where we go a bit deeper actually in the plans. So we have actually the plan C users for 4 countries for now, which is already a good step. And you can see here that we have also query plan C uses, which will actually allow us to do query, so to work a bit the other way around, where we can actually select what do we want. But I will just show you this part for now. So for example, if I click on this polygon here, it will give me that. So this is in Sweden. Priority CUs, it's recreation areas. And you have always use description, it's area for recreation and outdoor life. This is actually in Sweden, but if you go actually in Latvia, when you click here, you have priority CUs, maritime transport area, so prioritized for shipping, but you have also forbidden CUs, offshore wind farms. And this is why actually each polygons are lines in the database, because they can have actually one CUs types, at least one, but they can have 2 or 3 or 4. I think if I click on another one, we can have another example, maybe. Here, for example, in this area, it's a buffer zone of radars, but it's restricted for offshore wind farm. So it's the problem with this plans use was the countries are not doing their plans and they don't have the same categorization. It's not harmonized. So this is why actually the different areas can have different use types. I think I can show you quickly the query. This is actually, so as I say, it's to work the other way around, where actually you can choose, you can select the activities that you want, and then you will see it appearing on the map. I think we can go back to the slide. I'm sorry, I think we planned that we would do the other way around, but yes, I think we can go back to the slide. Perfect. So if you go next slide, next slide, please. Yes, perfect. So how to get this data actually? Well, the countries are uploading the data following the guidelines that I just talked at the beginning of the presentation. And there is actually a validation tool for the attributes and other technical aspects of the shapefile that the authorities will upload. When the data is validated, the shapefiles are actually, because there are like many shapefiles, so per country, but also sometimes per different CUs types and so on. So all of those shapefiles are actually turned into a file geodatabase and then it's published. There is a versioning at every update to be sure that we can actually track the update and we can go backwards if there are some issues or if we have to document or if the countries have to document something. And I said there are now 4 countries working with this. We hope that we will have more countries, but at least it's the beginning of something. And I think that's it from my side. Thank you very much. And please, yeah, if I can add, if you want technical question, please ask Andre, because he's the one working behind the machine, if I can say. So he will be able to really answer technical questions about how how the work is done in the database and so on. Thank you very much.
Thank you a lot for this presentation of BaseMap. It's actually very good solution and actually operative. Thanks a lot for this.
Thank you.
We're going to continue with other solution that is based for harmonization of MSP plans. It is developed it is finalized within the project Msp, which actually we call it this solution MSP Inspired Data Model. So the idea was to find inspired data model that can be reused, and we actually identified planned land use data model for difference of the previous solution that we're talking about, the sample land use and the land use that was presented now by Florent. So this data model actually has 4 features. The first one is a parental feature, which actually is a special plan that includes all other features inside. Of course, all possible zoning elements that actually explaining what is this planning about. But also, this solution has a supplementary regulation. These are the polygons that are actually includes prohibition or actually environmental protection or implementation of any environmental or any other legislation that should be considered with the plan actually special. And there is a 4th feature, which is not a special feature. This is the official documentation, which actually provides information, a link where you can actually download the information of the official documentation of it. So when we go inside of the model, we went to the zoning element and we see, okay, there is 4 compulsory attributes, the identifier, geometry, and then we have a classification of the zoning. And this classification is delivered within the hierarchy inspired land use classification system. This is a code list and it's a closed code list. And when we try to see if we can map it, current maritime special plan with this code list, we said, okay, this is possible, we can map it, but the code list, which is closed, it was very broad. So we were losing information. For example, for the maritime lanes, harbors, anchoring areas, or separation maritime lanes, everything was mapped with a water transport, which you can see that we lose really lots of information. But Inspire usually has a possibility to have other code lists. They used one developed by the data provider, and this we have a specific land use classification system. So we try to see if there is another classification system that we can use. Then CDataNet actually provided 3 types of code lists that we use. There is one from eminent human activities that was more populated within the about 50 codes. But still, we were thinking that would be very interesting to have a same classification system, this Hilux, on the land and the sea, but within the more precision. So we could not extend the code list because Hilux was closed. We say, okay, let's extend the data model. So the zoning element, we extended the MSP zoning element, and we include one more attribute, which we called Hilux MSP. So we developed the register, which was actually copied the register from the Inspire. We copied the code list from Inspire register and we included here, but we actually extended with the child values that provide the harbor, the maritime lane, all these specific classification that are necessary for the maritime. So we also have this code list we are managing, and when we see that there is something is missing or somebody is saying, okay, you have to include one more, we can actually very easy add within the register a new value that can. The second thing, what we were seeing within the passing the land planning model to the maritime planning, we see that land planning is mostly two-dimensional activity. And then when we see it with the maritime spatial planning, we had activities that are on the surface and that are on the seabed, so they don't have interaction. There is a very big space between them. Also, we have activities that start from the surface and they are finishing in the subsoil. They're extending through the whole water column. And this is why we actually decided to again extend the model and include another compulsory attribute, which we call vertical distribution. And this vertical distribution attribute can have a sea surface, water column, seabed, subsoil value, or any possible combination what actually. So this solution, we made a workshop on the Tenerife last year. We invited experts in GIS SDI. Yolanda was with us last year, Olvido as well. But also we invited not just the GIS SDI experts, we also wanted to invite the MSP experts. Some of them are not using, most of them are not using GIS in their everyday work. So we wanted to discuss this data model conceptually, but we also wanted to try. Again, we made a hands-on session. And for this hands-on session, we offered the flat version. Again, like for the habitat, we flat the MSP inspired data model. We provided the GeoPackage solution. Also, we are providing GML. And we have the hands-on session with a real use case. Actually, the Director Regional of Madeira, who is responsible for Maritime Spatial Planning of Madeira, kindly offered their draft for this workshop. So on the workshop, we were actually trying and testing the real use case, and this was quite successful. Everybody on the workshop were able to develop Inspire compliant plan, and this is what we have. This draft is actually the first Inspire compliant plan, I believe. And then after that, after the workshop, we did some modification that we see that should be done, and then we developed the data specification document, actually explain how to deal with the Inspire GML, but also how to deal with the GeoPackage, and also kind of the Inspire-like solution that then you have to transform. But you have like three type of, for the experts, for medium experts, and for the rocky user, the shape, also the shape. So just on the end, I would like to say what are the advantages of this model. Of course, you can harmonize it as it's actually delivered within the base maps. And when you have the harmonized MSP, you can actually analyze the coherency of the MSP on the regional development. No? So that doesn't happen that you have maritime traffic and that actually disappear when you cross the border, what we could see within the previously developed. Also, we see that using the same classification system, HiLux and extended HiLux, for the land and sea give us a lot of possibility with integration of sea and the land. We can actually automate, we believe that we can automate the land scene interaction analysis for the complicated coasts like archipelagos or the coasts that have lots of islands. Using these two systems, this could be very, very interesting. Combining the Inspire data which is coming on the land use within the maritime. Also, we believe that this data model can be a base for the cumulative impact analysis, which we are going to test it and try to do something with this with the Plasma Plus project that started this year and years. And at the end, what Irene mentioned, what we're talking about, the reporting environmental legislation, which is developed by XML mainly. The MSP reporting could be possibly done with the GML, which is actually more or less the same thing. And also, I would like to mention that for this reporting could be used already operational Inspire spatial data infrastructure that is operational in the European countries for quite long. So yeah, this is from my side, and I would like to go on our next presenter. Next presenter is Olvido Telha. She is a geologist and she works in the Spanish Institute of Oceanography. She's a specialist in GIS and spatial data infrastructure and marine cartography. And she is a coordinator of institutional GIS of the Institute. She developed this work with Gerardo Burke, who is a He's marine scientist also in the Spanish Institute of Oceanography, together with Luis Miguel Agudo. is geologist and developer. Olvido, please unmute yourself, and if you can, put your camera on.
Okay. Can you hear me?
Yes, very well.
Okay. Good afternoon to everyone. We would like to thank Andre and the organizers the opportunity to present this work using a common style layer description SLD as solution to standardize the symbology in an Msp data model. Next, please. With this presentation, we would like to emphasize the importance to use common styles for portrayal in the process of harmonizing maritime spatial plans. In this way, the Msp project has been a perfect opportunity to develop the common style for portrayal, working on a real use case in the archipelago of Madeira. The proposal to standardize the symbology is the use a common style layer description, SLD. We have developed a SLD based on a set of symbols also created by us. This symbol corresponds to all spatial objects in the extended HiLux developed by EcoAqua. The SLD is a profile on the WWF service encoding standard, and both are OpenGIS standard. And SLD define an encoding to allow the users to define a symbology of spatial data. Next, please. How standardize the symbology for the Msp data model? Initially, we have investigated the standards which already exists in symbology for marine cartography. For instance, the symbols of the International Hydrographic Organization. Unfortunately, it did not work because it was based on point figures or icons and images and did not provide good visibility in the case of layer overlapping. Later, we examined some web map service related to Msp in order to analyze if any homogeneous representation existed for the same plane land use, or at least with some analogy. But we did not find this similarity or analogy. Finally, we decided to design a general portrayal structure for the Msp data model created by EcoAqua. The Msp data model is based on the plan last use data model, which is mainly based on zoning element and supplemental regulation, and Andre said. Next, please. The HiLux is divided into 6 main categories, and for each one of these 6 main classes, a color was assigned, and all the symbols within then have a similar tone. Two different patterns or geometrical frame styles were assigned to the next level within the hierarchical structure. At each next level of detail, different geometrical frames were established within the style of the upper level. Between them, there are different values of angle, offset, separation. You can see the 6 classes, and you can see a detail of the 3 class tertiary production. You can see the symbols and a list of all symbols. Next, please. In the case of land use supplementary regulation, the methodology is similar, but in this case, not integer pattern was chosen, only the outer line, in order to, after when need to overlap 2 categories, the symbology is better to see. Next, please. To generate the SLD, we can work first with our map. In our case, we can with our map to be able to generate a style file in SRI format. We can load this file in QGIS using a plugin called SLYR This plugin is possible to download in the hub. Then we can export it to a SLD format directly from QGIS. Other possibility is working directly in QGIS. Next, please. This methodology using ArMap or QGIS to generate the symbology has some problem because the software use their own fonts, and in this case, it is sometimes necessary to have this font already installed in the server where this SLD is hosted. We can solve this problem by editing SLD file using any text editor and changing the symbol that use external libraries for another symbol. We can find information about SLD format in GeoServer web. It is very useful to check these tutorials in GeoServer because some of them allow us to have values in QGIS SD file that are not allowed in GeoServer. In our case, the layer to symbolize must have the field Hilux MSP 0.1.8 RAF because this data will be must symbolized through it via a rule or filter defined by the standard LSD. Next, please. This is an example of SLD code used to symbolize carbon capture areas in our layer. Next, please. Finally, we load the SLD file in a web app server, in our case, GeoServer, using the style tools and validating with these tools the SLD file. The last step is to set the WMS style property and allowing us to use the style created. Next, please. In the slide, you can see the results of the portrait. Sorry, this is the use case in Madeira, and this is the style for the land use zoning element. You can see the different symbology and the complex of this symbology. And next, please. And in this slide, you can see the styles fold supplementary regulation overlapping with zoning regulation. This is the results. Okay, thank you very much. Next.
Thank you, Olvida, very much for this presentation. It was very good, and I think it's shown the idea how complex it is actually develop the symbology for especially for the small islands where we have lots of overlapping and where we have how did you resolve this problem? So now we don't have more presentation. Now we can go to the questions. Is there any question?
Okay. Yes, I was monitoring the chat, and most of the questions have been already answered by some participants. So let's start from last question that is raised to Olvido. Could you please provide the link to GitHub in the chat?
Yes.
Thank you. And there is a question from Lena to, I think, to Andre. Asking for more explanation if you used specific supplementary regulation in addition to extending the Hilux to MSP Hilux.
Okay, yeah. This is okay. This is very nice question. But what we did, we use it the extended Hilux. We could use the also supplementary regulation. Maybe we could use the EMODNet list what we find on the CDataNet. In this case of the Madeira, which was also presented by Olvido, we didn't use it, but actually it would be very simple to include it. Just we would need to map what we have this code list again. But yeah, it's possible. Very easy and very possible. Thank you for the question.
Thank you. And I would like to raise another question, which had quite a lot of discussion. So the question was more related. If there are any marine special planning related groups within Inspire that have a related experience or are interested in coordinating with the development of standards like OGC, or if this work on marine spatial planning inside INSPIRE is coordinated now and further developed with ISO standard as well. ISO standard mentioned is 19152.
Okay, yeah, this is also very interesting. This is a question from DVG, the group that works with, if I'm okay, with the maritime standards. And what you see, well, there is an expert group that we're going to be mentioned a little bit later about this. There is an expert group on MSP data, and which started to work, let's say, a few months ago. We had actually first meeting before 20 days, working meeting. It's a technical group which actually tried to see what are the solutions which were presented today, and to see if there is that we see the benchmark and understand which solution has, let's say, what are the good solutions with one solution, when with the other, maybe develop some hybrid or something that could be used at the end for the member states on the level of Europe. Maybe this group could be most similar what is asked, but I wouldn't know for further.
Mm-hmm. Thank you. So maybe here I can say something from the INSPIRE side. There is also INSPIRE Community Forum, which is open to different interests, different experts, where you can also raise certain questions and the community can help to answer. So this can be maybe a way to start some discussions on this particular issue on INSPIRE Community Forum as well. And maybe just the last question was addressed to Yolanda. You already answered, but still I would like to ask you for your reply. So the question is, how do you validate that your GML files are fully compliant? And do you have clients example that consume those GML files? Please.
Yes. In fact, the GML that we produced was validated using an online validator tool, which is called the ETF validator, which I add in the chat the URL in which you can find this validator. The result was not completely error-free. We only but we only had one error related to the valid from and valid to fields. That in fact, when you add, sometimes we don't have this information in the original data sets. So we couldn't do nothing to overcome this error, but the rest of the requirements were met. And regarding the clients that we tested to see if we could see the complex GML structure in a GIS desktop, we used one plugin from QGIS, which is called the GML QGIS GML application schema toolbox that is able to read complex GMLs. In our case, it was reading most of the fields, but not all of them. Some information was not correctly shown in the tree, but some of them, yes. And this is the only tool we tested.
Thank you. Maybe the last comment from Alessandro Stratta, who supports Andrei in consideration on technical expert group on NMSP data that can be working on standardization towards OGC and INSPIRE. So that would be all from chat.
Okay, Daria, thank you a lot for following this. I see there was a kind of discussion during this session, and this is also very, very good.
We will save chat as well for you, so that you can go through information and maybe reply to participants later as if needed.
Perfect. Thank you a lot for this. So maybe we can finalize this because I see there is not so many, no more questions. They were working on questions during the workshop, and maybe we can go for the conclusion and workshop wrap up. Clement from System Mechanism will do this. Clement, are you here?
Yeah, it should be coming to you now. Can you hear me, see me?
Yeah, we can hear you.
Sorry, Andre, if I may interrupt. Please, Clement, if you can do in 5 minutes, because at 4 o'clock we are starting closing sessions. So, please.
Yeah, I'll be short.
Thank you, Vlado. Yeah, I think
Okay.
we're going to be perfect. Thanks.
Okay, thanks to all. Thanks, Andre. So yeah, I'll try to do that in 5 minutes. I'm not going to go into technical aspects. I think we've had a clear overview of these just before. So I believe, to be short, that we all know that getting to inspire standards is going to be more and more crucial for MSP, be it to harmonize standards, languages, and that's with regards to environment, but also and more especially human activities. We can see, and we've seen that from presentations, that there's a variety of solutions that are developed all across Europe, with a strong experience on MSFD and maybe a more recent one on MSP. And we can see that those merges very well with the cumulative impacts subjects. I think that's a major one. As Andre just recalled, this is a major area of interest for the recently created technical expert group on MSP and data. That was also something that was talked about in the chat section. So yeah, definitely the goal of the TDA is to collaboratively aim at defining, proposing standardized approaches to develop, or at least propose data models, data flows, and standards that could be shared all across Europe. That's definitely one of the major goals for this group, and I think we can build on the presentations that have been delivered today. I believe most of you, at least the presenters, are already included in the TJ. For those who didn't know about it or missed the information, we will send out links to the registry of documents and all the information on this group, so that you can join and actively participate in it. I think from the MSP AM and platform, that's it on my side. And thanks again for all of you and these presentations. I don't know, Andre, if you want to add something about this.
Yeah, thank you, Clement, for this wrap up. Yeah, we just need to finalize this because we have a closing of the conference. I would like, before we finish, I would like just to thank you everyone for doing this online. We're not been able to go to the Browning, but everybody was without a problem, did the same online. And also would like to thank lots of Daria, who was hosting and carrying out that everything works fine. And of course, Vlado and GRC team, who organized this conference virtual online. And I think this was a very, very difficult, but yeah, it was still developed, and we could actually share our knowledge and what we developed in last year. So hopefully we see next year in Dubrovnik with a presentation, not on the virtual way, and I think we can close the session. Thank you very much for attending the workshop.